Good morning, dear participant. I am Dr. Nabil Ahmed, Professor and Dean at the School of Allied Sciences, Devbhoomi Uttarakhand University, and I'll be presenting my work on green synthesis and biomedical application of selenium nanoparticle via Rosa damascena leaf extract. I would like to thank the organizer for the Biological and Chemical Sciences conference for providing me the opportunity to present my research work. So moving for the next slide, selenium nanoparticle is also known as SENPs, and SNPs are a type of nanoscale material which is composed of primarily of selenium atoms. Selenium is a chemical element which is having atomic number of 34 and is an essential trace element for the human and many other organisms. It also plays a crucial role in various biological processes, including antioxidant defense, thyroid hormone metabolism, and immune functions. Selenium nanoparticles have gained significant attention in recent years due to their unique properties and potential application in various fields, including medicine or medical fields, electronics, and environmental sciences. Uh, Selenium, which is an essential kind of poison, it has been a controversial nutrient because too much selenium in the diet can be a lethal, and whereas too less can cause in a chronic and mostly fatal deficiencies. Selenium nanoparticle are biologically compatible, and it is having a kind of solubility in nature and inoffensive in nature, because of which greater bioactivity selenium nanoparticle are highly occupied in several medical specialty. Basically, it is possible to synthesize selenium nanoparticle as a result of physical method, chemical method, and biological method. Selenium nanoparticle can be synthesized through various different method like chemical method, physical method, and biological methods. Chemical methods including reduction of the selenium salts with reducing agents like sodium borohydride or hydrazine solver thermal synthesis and microwave assisted synthesis. Whereas the use of the green synthesis methods includes the use of microorganisms, plant extract, or biomolecules like proteins or enzymes have gained a popularity due to their eco-friendliness and potential for large-scale production. Whereas the physical methods such as laser ablation, vaporization, and electrodeposition can also be used to produce for the synthesis of selenium nanoparticles. Uh, this present study is to design a eco-friendly mode to the ultra-fast method to synthesize the selenium nanoparticle by simply mixing the extract of Rosa damascena in the sodium selenite solution. So there are the certain advantage of the use of the plant extract. Uh, Basically, it has a faster method. There is no need for maintenance any specific condition for the media or something for the maintenance purpose. So plant extract also contain a kind of cofactors, enzyme and flavonoids and terpenoids to serve as a reducing and capping agents. So talking about the basic methodology, first plant extract was prepared by collecting fresh plant material and wash it through thoroughly and grinding into a paste, where the bioactive compounds were extracted by heating the paste with the distilled water, and the resulting the extract was filtered to remove the solid debris through centrifugation or through filter paper. Meanwhile, a sodium selenite solution was prepared by dissolving a specific amount of sodium selenite in deionized water. The plant extract and the sodium selenite solution were then mixed in a reaction vessel with the plant extract serving as the both reducing and capping agent. This mixture was heated to a controlled temperature between the 60 to 90 degrees centigrade while stirring continuously for a defined duration. A noticeable Change of color was observed from colorless to red or orange occurred during the reaction. It indicates the formation of the selenium nanoparticle. Following synthesis, the nanoparticle were further characterized by UV visible spectroscopy, transmission electron microscopy, dynamic light scattering method. The nanoparticle were also analyzed by using the FTIR to confirm the presence of the functional group from the plant extract on their surface. After purification to remove the excess reactant or byproduct, selenium nanoparticle were stored in a suitable solvent in a cool or dark place to prevent the aggregation or degradation purpose. It has been well evident from the previous work, the polyphenol content in the leaf extract could reduce the selenium ions to form the metallic selenium nanoparticle. In this work, the Rosa damascena extract was employed as a reductant to synthesize the selenium nanoparticle. Figure A shows the UV visible spectrum and the optical images of the resultant selenium nanoparticle. The synthesis of the selenium nanoparticle determined by the UV visible spectrum showed SPR at 315 nm. The FTIR spectrum rapidly synthesized selenium nanoparticle as shown in figure B. Broad vibration peak at 3430 per centimeter correspond to OH string of the alcohol and phenol groups. Absorption peak at 2977 and 2880 per centimeter represent the carbon hydrogen stretch of the alkynes groups. The small vibration peak correspond to the bending carbon hydrogen bond or carbon nitrogen or oxygen hydrogen or carbon nitrogen or carbon stretch attribute to alkanes or amines and carboxylic group. However, these functional groups are confirms the involvement of the different reducing and stabilizing agent in the synthesis of the selenium nanoparticle. Further, selenium nanoparticle morphology was confirmed by field emission scanning electron microscope. The FE SEM images clearly reveals the monoscattering and uniform spherical morphology of the particles. Selenium nanoparticle have applications in drug delivery system, particularly for anti-cancer drugs. They can be functionalized with targeting ligands to deliver a drug specifically to the cancer cells with reducing side effects. If we talk about the nutritional supplements, due to their bioavailability, selenium nanoparticle can be used as a more efficiently form of the selenium supplementation in the human diet. If we talk about in the field of the electronics, selenium nanoparticle have shown a promise in the development of the electronic devices, including the solar cells, photodetectors, and sensor due to their unique electronic properties. If we talk about the environmental remediation, selenium nanoparticle can be used for the removal of the heavy metals and other pollutants from the water and soil through adsorption and catalytic process. And if we talk about the in the field of the cosmetics, selenium nanoparticle are used in the cosmetic products for their antioxidant and skin improving properties. Due to the importance of the selenium nanoparticles at the tissue and cellular levels, biological applications of the selenium nanoparticle have recently attracted the attention of the numerous researchers, scientists, or academicians. Selenium nanoparticle, or we can say that nanoselenium, is a kind of the nanomedicine, has a number of beneficial qualities, including the antioxidant, antibacterial, anti-cancer, anti-diabetic, and anti-parasitic effects. The use of the excessive order of the selenium nanoparticle exhibited enhanced therapeutic effects such as the antibacterial, cytotoxic, and antidiabetic and chemotherapeutic that can be used as a theranostic and healing agents. Recent studies using in vitro or in vivo methods demonstrate the anti-cancer properties of the selenium nanoparticle, efficacy against the breast cancer, lung cancer, kidney and osteosarcoma and malignancies. This slide is the conclusion. The use of the plant extract in the green synthesis has become a very popular because no toxic solvent or highly temperature is required. The synthesis of the selenium nanoparticle was characterized by UV spectrophotometer, FTIR, TEM, SEM, and the synthesized selenium nanoparticle determined by the UV visible spectrum showed a peak at 315 nm. The prepared nanoparticle had a spherical and polydispersed in shape and having a size of 40 to 60 nanometer. And these green synthesized selenium nanoparticles showed a significant activity against both the antibacterial and antifungal species. In conclusion, selenium nanoparticle are a versatile nanomaterial with unique properties and promising application in various fields. Their synthesis methods, properties, and potential application make them a subject of active research, and further studies are need to unlock their full potential while ensuring safety and sustainability in their use. Thank you so much. Once again, I would like to thank the organizer of the Biological and Chemical Sciences Conference for providing me the opportunity and congratulate them for successfully organizing this conference. Thank you. Thank you so much.